2010 number 6 has to do with differential equation. Now, even though this particular problem, and also in the entire 2006 free response questions, even though it does not deal with anything that look like a slope field problems, because there is no problem that shows up graphs or you have to kind of draw out the slope field. But slope field has to do with differential equation, and look at this. This is differential equation. Immediately the problem sets up with differential equation. You have dy dx equal to xy cubed. As you can see, x and y are mixed. D squared y dx squared, this is a notation for second derivative, and you have this particular function, this particular relation. Okay, and then not only that, it says that there is a very particular solution with f of 1 equal to 2. Okay, so I wrote these three pieces of information down here so that later on, as I go through the problem, it will be right there for me to refer back to. So let's go to part A. Part A says we want to write an equation for the line tangent to the graph at x equal to 1. Now notice, at x equal to 1, f is equal to 2. So we know that in order to find the equation of a tangent line, first of all, equation of a line, we need point and slope. Right? Now point here, we know the point is 1 and 2. We know that because when x is equal to 1, f of x is equal to 2. Slope, well, slope is the first derivative, or dy dx. And dy dx is dictated by x and times y cubed, and we're evaluating from 1 to 2. So what we can do is we can go ahead and put 1 into x and put 2 into y. So we got 1 times 2 cubed, and we get 8. So now we're ready to write an equation of the tangent line. Y minus y1 is equal to mx minus x1. So we get y minus 2 is equal to 8 times x minus 1. Now that is the equation that you can use. This is the equation that you can leave as the answer. Now, of course, certainly you can go ahead and simplify it if you like, and perhaps once you simplify it, it might be easier for the next part of the problem. But regardless, this is good enough. But for sake of simplicity, I'm just going to go ahead and simplify this. This becomes y equal to y is equal to 8x minus 6. Okay. Part B. Now part B says use this tangent line, or this line, I mean it's the same line, use this tangent line to approximate f of 1.1. Okay, so what does this mean? And then not only that, it says now that explain whether this value is going to be bigger or greater or less than the actual f of 1.1. Explain the reasoning. So, this is how we think about it. Conceptually, if you think about a graph like this, okay, you think of a graph, and I'm just going to go ahead and exaggerate this. Pretend that this is the f of x, the actual f of x. And we don't really know if this is true, but this is just how we conceptualize it. Now, if we say at x equal to 1, we know that this is equal to 2. Okay? And what it does is that it gives us, and remember, from part A, based on this differential equation, there's a f of x, and based on part A, we found the equation of the tangent line, which is basically, it's this line right here. This is y equal to 8x minus 6. Right? This is this graph. Now, right now, we want to approximate f of 1.1. 1.1. So, and we are asked to use this equation, this tangent line, to approximate this. So the idea is this, is that your real answer is right here. This is a real answer. But we have no way to get to it because we don't have an equation for this function. But what we do have is this tangent line, which gives us this value. Okay? This is a true value. This is a true value. But this is the approximate value. So we say, well, what is that answer? Well, that's very simple. We can say 8 times 1.1 minus 6, and we get 2.8. We say the answer is 2.8. The approximate answer for the true f of 1.1 is 2.8. So at least we got that part right. The question here says, well, is this answer bigger or smaller than the true value? Now, based on my assumption right here, this answer is smaller than true value. But it is possible to have another case. It is possible that the true f of x does not look like this. The true f of x could look like this. That goes the other way. So the question is this one the true f of x, or this one the true f of x? And how do I know that? And by knowing that, then I will be able to know whether this true value, or this approximate value, is smaller than the true value if this is true, if this function is true, or bigger than this true value if this function is true. And how do I know that? The difference between this function, or this configuration, and this configuration is that this one concaves up, and this one concaves down. Concaves down and concavity of up and down depending on what's going on here at x equal to 1. Now how do I know the concavity? Well, concavity comes from second derivative, right? We have second derivative, d squared y over dx squared, which is second derivative, and we want to know what's going on at x equal to 1, y equal to 2. Well, so if that's the case, then I can put 2 into y, right? So 2q times 1 plus 3 times 1 squared times 2 squared. And if I calculate this, my answer turns out to be a positive, right? I don't even have to finish writing this. I just know that this is positive. Now, if it's positive, that means this graph is the actual graph, and this one is not. Then I can say 2.8 is less than the true f of 1.1 because of the concavity, and this is my reason. Okay, so that's part B, and let's go into part C. In part C, you will find that it is exactly the same kind of problem that we've done over and over in chapter 7. Part C says find a particular solution with the initial condition of f of 1 equal to 2. Particular solution. Well, what are we talking about? Well, we're talking about solving the differential equation. dy dx is equal to x times y cubed. Well, we know that the first step of solving this problem is to separate variables. So we put dy over y cubed down here, and we get x times dx. And we integrate on both sides. And this one, don't be tempted to solve this as ln y cubed, because it's not. This is equivalent of y to the negative 3 dy, and this is x dx. So we get y to the negative 2 over 2 is equal to x squared over, actually y to the negative 2 over negative 2 equal to x squared over 2, x squared over 2 plus c. Okay? And you can say plus c1 if you like, and you can go ahead and solve that. And then what you can do is you can go ahead and fill this out, or you can solve this first. I think what we can do is we can go ahead and solve for C1. So we get this is 1 over negative 2 times y squared, so it's 2 squared is equal to 1 squared over 2 plus c. And this is so negative 1/8 is equal to 1/2 plus c. So c is equal to negative 1/8 minus 1/2. Okay. So we get negative 1/8 minus 4/8. So we get negative 5/8 plus c. So your solution, your answer is negative 1 over 2y is equal to x squared over 2 minus 5/8. Now we can certainly solve this by turning this into negative 1 over 2y equal to 4x squared minus 5 over 8. We can flip the whole thing. We end up with negative 2y is equal to 8 over 4x squared minus 5. And we can say y is equal to negative 4 over 4x squared minus 5. So that's my final answer.